Hi, welcome to the Calculus 1 lecture series. And this is our lecture number 4. And we are still in the unit number 1. We talk about the limits and the derivatives. So in this lecture, number 4, we're going to talk about the continuity. And so is how do we define a function is continuous or not? And as a previous lecture, because this lecture is a long lecture, so we're going to divide it into 2 videos as well. And so the first video, we're going to talk about the continuity definitions and how do we define the functions continuous in an interval and the different type of discontinuity points. Then the second video we're going to talk about, we call it the intermediate value theories here. Okay, so let's go ahead and get started. So let me go to our lecture notes here. Okay, so the first things here, we said, okay, let's go ahead and define what is the continuities here. So the continuity, if you look, the functions, right? So if you look at the graph of the function, so if this is my graph here, and from this is A, this is B, and so we say it's a continuous in this. Here is kind of like obvious. You see this function is a continuous going without stopping, right? So the same way, like from the graphing. So if you have a function like here, then you function like that, then this function obviously, if this is my A points here, this function obviously is a discontinuous function here, right? Because you got to jump here. So now from graph is obvious to see, but what is the definition about the continuous, right? So we said that if we know f is continuous, okay, so what is the, what is the conditions here? So the first conditions here is like a limit x approach to a, f of x has to be exist. And the function value has to exist. Okay, so the first, this is kind of like the one level higher. So like kind of a hierarchy. We first talk about the limits. So we said the limits exist as long as your right-hand side approach equal to left-hand side approach, they are equal, then we'll say the limit exists. We haven't, we don't, sometimes like, for example, if you still remember, if I have a function like this, right? So if this is the function and if this is A, so we say the limits when f of x approach to A exist because why? Because you approach from the right-hand side, you approach from the left-hand side, they all approach these values here. We call this L. So it exists. But also from the graph, you can see obviously this function is not continuous. It's because this is my function values, right? So this solid dot is my function value. So in order, so that's why we said this is the one level higher than the limit exists. So we said the limit has to exist. The function value has to exist. And what is the in here, they not only exist, right? So like this problem is here. So function value exists is here. Limit exists is here, is L. But obviously it's still discontinuous. So in order to be continuous, so we say the limit has to be what? Has to be equal to the function values here. So that's why we add one more conditions here, right? So limit is not only need to be exist, and also it has to be equal to the function values here. Okay, so now let's take a look at, what are some common type of the functions here, right? So let's take a look at here. The first one here is polynomial. Okay, polynomial, so something we have is in here. So f equal to the 3x fifths minus 5x squared plus 3. So this one's here, where it is a continuous, this one is a continuous where? So for all the real numbers, right? Because the polynomials here, there's every real numbers here, the limits will be exist. Okay, so now let's take a look at the rational number. The rational function, this is the one we said is what? Is with the fractions, right? So for example, f of x is equal to, so if I have this is x plus 1, x minus 2. So we know these functions here is what? I cannot have x equal to -1, cannot have x equal to -2, a positive 2, right? So for a rational function, where this is continuous, so this is where is continuous, right? So we know is all the real number, but I need to what? I need to exclude the number, make the denominator equal to 0, except the x value, and make the what? The denominator equal to 0, right? So that's what is a rational number. Okay, let's take a look at the roots here. Okay, so take a look at the roots number. So the roots here is, we say the f of x is equal to something here and to the nth roots here. So we know for the nth roots here, so where is this is continuous? We know, okay, so if L is all real number, but if n is even, right? So that means inside the even roots cannot be what? Cannot be negative. So even it's a real number, then except the what? Except the x values, make the roots inside the roots what? Inside the roots less than 0, right? So how about if here, if n is odd numbers here, so if n here is odd number, then what happens? So if it's odd, then it's all real number will work, right? Okay, so the same thing you can think about. So the basically, for the function, you need to know where is the functions, the domains, right? So for examples here, if I take a look at the exponential. So the exponential functions, so like something we have f of x is equal to, let's say here, 3 to the x here. So I know what is the continuous here. Oh, because that means it's all the real numbers, right? Because there's nothing, so the domains of exponential functions is defined, it's all the real number. So the same things here, let's take a look at the logarithm, okay? So if you take a look at the logarithm function, so let's take a look at, for example, it's natural log x. So what is the domains here? So the domain for the log is greater than or equal to 0, right? So here we have to be the x value makes the inside what? Inside the log is non-negative, the greater than or equal to 0, greater than 0, right? So it has to be inside the log here, right? So inside the log here will be what? Is greater than 0, right? So because I know okay, so it's greater than 0, right? So that's why when you look at the function, you define the continuity. So the first things here you need to take a look at is this function where is the, where is the domain defined? Is anything is outside the domain? And then of course it's outside the domain. I cannot talk about the continuities here, right? Okay, so now we said limits we have from the right and the limits we have from the the left. So the same thing is the continuities here. So when we say a continuity from the right, what's that means? That means in here, so the same things here you say is limit x approach to a from the right-hand side here, right? So here, let's put the color one. So we see, so that means I'm approach from the right-hand side here, then for the f of x. So it's the same thing, similar like the limit. So you approach from the right-hand side, that means then the function value will be equal to the f of x here. Then the same thing, we say, hey, the continuity from the left. So what's that mean? That means x approach to a from the what? From the left-hand side here, right? So then the f of x is here is equal to what? F of a here. Okay, all right. So now the last things here, we say, how about if we say a continuous close on a closed interval here, in a closed interval AB here? What's that mean here? Okay, let's take a look at the graph here, right? So here, this is the A, this is the B here, and I have a functions like that. This is f of x. So obviously, you know, this function is continuous, right? So like we said, if continuous on this interval, what's that means here? So we said if f is continuous or closed interval, what is the condition? That means if f is what? You know, so that means when you go this way here, right? So when you closer to the boundaries here. So what is this one? This is right approaches, right? So that's why we say f is right continuous at A. Okay, and also then the same way, because you are approaching to this end, so you go do here, right? So what is this approach? Is left approaches, right? So then we say f is left continuous at what? At B. And of course, then it has to be continuous on the every point, and also is what? Is continuous at every point. At every point in the open parentheses, right? And that's why we say it's a continuous in this closed interval. So three conditions, right? So it has to be right continuous, it has to be left continuous, of course. Then everything, right? So now we know that everything inside this interval AB here has to be continuous. So it's three continuous conditions here. Okay, so that's how do we define a function is closed, you know, it's a continuous or closed intervals here, right? So be very careful here. This means this is the closed intervals here. Okay, so now let's take a look here, right? So now let's take a look here. Determine the point where it is not continuous, all right? So let's take a look. All right, so you look at the graph, obviously, what is my first point? This point, right? So I know x equal to -2 is not continuous because this is the function value and both of them. So you see the, you know, the curve is not continuous, it's kind of obvious. Now, what is the next one here? You see this function, then boom, jump to here. So what is the other point is not continuous? X equal to 0. What is the other one? Is not continuous here. You see here, right? So it's continuous, boom, here, and then drop down here. So what is here? X equal to 2, right? From the graph, it's quite obvious. Okay, now let's take a look here, right? And the second example here, let's try to make sure we understand the definition of the continuous. So let's say, first one's here. Yes, the f is a continuous, is -4 to 3. -4 to 3 is from here to here. So this is my function. Is it continuous? Yes, it's continuous to the left, continuous to the right. right? So this is what? This is yes. Okay, so now the next ones here is 0.5 to 1.5. 0.5 is here, 1.5 is here. So is this portion is continuous? Yes, right? Because it's yes, and it's continuous to the left and continuous to the right. Okay, so then the next ones here, let's take a look here. So it says -1 to +1. Okay, so -1 is here, right? So it's this function to the +1. So it's in this region. So here, then when it hit the 0, what? They jump. So this is a continuous in this closed interval? No, right? Because I got a jumping point here. Okay, so now let's take a look at the next ones here. The next ones here is -2 to -1. -2 is here, -1 is here. Okay, so -2 to -1, so it's here. So if you just look here, it's a continuous. But the problems here, right? So the problems here, be very careful. I have the -2 in the close parentheses here. So the close parenthesis, what's that means here? That means the limit x approach to -2. Because it's a close parenthesis, that means based on our definition, if I approach from the right, right? So if I approach from the right here, the f of x, so if it's a little bit bigger, so then like from the right is this way. So what is my limit going to be? Hey, my limit is going to be infinity. But if I put the f of -2, the function value of f of 2, what is here? It's here, it's 1s, right? So they are not equal. So what is this ones here? The answer here, this is no. Why? The reason why is because f of x is not continuous, right? The reason why is not continuous at x equal to the -2, right? Be very careful. That's what we say if you have a close parenthesis. Okay, now let's take a look at 0, 1s here. This one is very interesting also, right? Okay, 0, 1s, right? So, okay, so it's a closed interval for 0, 1s here. So let's take a look. 0, 1 is from here to here. Okay, so the 0 and the 1. Okay, so 1. Okay, so I'm sorry, I drew too much here. Okay, so 0 is from here, 1 is here, right? So this little piece of the green, maybe I should draw red. It's showing better. Okay, so you can see better here. All right, so this is the 0 to 1s, right? Okay, so now obviously 1 here is okay. How about the 0 is a close parenthesis here? Okay, so let's take a look. The 0 is a close parenthesis. So to do the same thing, so limit x approach to 0 from the right-hand side, f of x. Okay, so from the right-hand side, that means I'm going to do to here, right? So what is my limit going to approach to? My limit going to approach to 4. Then the same things here, if I put the f of the 0, what is the function value? If you erase this ones here, you can see here, right? So when the x is equal to 0, my function value is what? My function value is 4. They are equal. So I know the function is continuous at 0. So this is true or false? Is it continuous? Yes, because I have this 0, even it's a discontinuous point for the whole function, but it's continuous to the right, right? Okay, now let's take a look at the next ones here. -2 and the -1s here, okay? So the -2 and the -1, okay, let's erase this. And these ones here, be careful, I have open parentheses here. Okay, so the open parenthesis, that means it's not including the -2. That means it's in here from this is the functions, right? So because it's not including the -2, I don't need to worry about it. It's right continuous, left continuous. So is this continuous in the interval, like from the -2 open parenthesis to -1? Is it? Yes. All right, because this is the open intervals here, right? So I don't care, but that's why the differences, if you can take a look here, compare the differences between part D and the part F. So one is a closed interval. So I say it's not continuous. It's because the right-hand limit, the limit is not continuous at x equal to -2. And but in here, the -2 is open parentheses. Then that is fine, right? Because it's not in the domain we concern. Okay, so now the next one's here. So we said if the f of x is equal to the function is this f of x is x plus 1 x minus 2, x plus 1 is a continuous for all the real number. We say, hey, this is a fraction. The fractions, the problems here, the fraction cannot have the denominator equal to 0, right? So we say no. Okay, so we say this is no. Okay, so it's no. It's not a continuous at the all real functions. No, why? Because x equal to the -1 is not in the domains, right? Okay, so I know the f of -1 is what? Is not defined. So I know it's not a continuous at the x -1, but then you will say, hey, we just learned from the limit. So you say x plus 1 can cancel. So now, you change your function to the f of x is equal to x minus 2. Then this is a polynomial that should be continuous. So be careful here, right? So we know that, yeah, from the limit point, right, you can cancel that. But from function's point, x plus 1, x minus 2, x plus 1 is not equal to x minus 2 here, because this is what? So when okay, so let's see here. Okay, so for these functions here, right? I know this is the, so I know this is the line, but, if you just draw the f of x equal to 2, it will just be a line like this. But if you draw f of x here, did you see what happens here? You got a what? You got a hole here. That's the whole difference is here, because I know original functions, x plus 1 cannot be equal to 0. So I know x equal to -1 is not in the, I'm sorry here. So the x equal to the -1, so it should be -3 here. So I'm sorry here, not in here. The whole, I drew the wrong things here. So, oh boy. Okay. Okay, so I'm sorry here. So this is the host, right? So when x equal to -1, see here. So this is the host, see here. All right, so that is why. Okay, so this is the whole. So that means that's why when you draw, if you draw the whole f of x, it still a line, but you have a host here. So that's why these two functions not exist here. Okay, so it's very, very important. Yes, we did it for the limit. Limits is fine. So we know the limits here, if you approach from the left, approach from the right, and the limit is equal to -3. all right? But it's not a continuous. Be very careful. Okay, so now let's take a look, like a problem number 3 is here. So problem number 3 say, hey, I have a root function, 1 minus x over x, where this is a continuous. We said, okay, when we talk about a continuous, we need to take a look at where is it defined. So the first, we know the x cannot be equal to what? Cannot be equal to 0, correct? It's because the denominator cannot be equal to 0. Now, what is the other things here? Hey, because this is what? This is the even roots. So the 1 minus x has to be what? Greater than or equal to 0. So the x has to be less than or equal to 1, cannot equal to 0. And the same way, the x has to be greater than 0, right? So the x has to be greater than 0 here. So where it is continuous here, it is continuous on where? Is from 0 to what? It's 0 to 1. So take a look here. I have open intervals, right? The reason why the open interval is because the denominator cannot be equal to 0. Okay, so now let's take a look at this ones here. We said f of x equal to the cosine 1 over x. What is the limit of the f of x? Is f continuous at x equal to 0? We know the trig function typical is continuous. So when the x is getting closer to zeros, right? So this 1 over x is going to become very big. But I know cosine is always between 1 and the negative 1. So let's take a look at this ones here. So this is xy, okay? And this is 1, and this is negative 1, right? So we know the cosine function is always between the 1 and negative 1, but when x approaches to 0, the function going to go like this. Right? So of course here, make sure, the 1 is here, right? So this is all inside of 1. So as you can see, when the x approach to 0, what happened to the cosine? It's jumping around here. So because this number approach to the infinity, so it's jumping around between the 1 and the negative 1s, right? So I know this values here is what? Is not exist. Right, so this is values sometimes going up and down, up and down, up and down. So it's f of x is continuous. Even this is a trig function. So what is the answer? We say no, it's not a continuous. Why? Why? Because limit not exist. Right, so remember, like when we first defined the continuity is what? The limit has to exist, and the limit has to equal to the function values here. Because when the f of you substitute the x equal to 0, you don't know what is this value. So the limit is not exist. Okay, so now let's take a look. We said, find the limit for this value, x approach to 0. So when first we say you plug in the 0, so what do you have here? You will have a limit, the 0 plus 1. So what is here? It's natural log 1. So what is natural log 1 here? Natural log 1 is 0 here. Okay, and the next ones here we said is f of x is continuous at x equal to the square root of 2. What is your answer? The answer is yes. Why? Why? It's because of what? Because of f of x is what? It's a polynomial. Right? So we said the polynomial is a continuous in where? Continuous at all real numbers, right? So of course, the square root of the 2 will be continuous. So it will be continuous at the square root of the 2. Okay, So the next things here, we're going to talk about the discontinuity. We say some point is continuous, some point is not continuous here. So let's take a look here. Okay, so like let's take a look at this one. Let me get a little bit bigger, right? Okay. Oops. Let me move over here. Oh, I don't like my. Okay, so let's. Okay, so here. Okay, so now let's take a look here. So the discontinuities here, like we say, obviously this function is discontinuous, right? Because I have a breaking point, I have the points here. So we have two kinds of discontinuity. The first one, we call this a jump discontinuities here. Okay, so the jump discontinuity from the graph is very easy. So we say jump, let me say you're jumping up. So here, this is the discontinuity we talk about. This is the jump, right? So at the A, so like in here, we said the jump discontinuity for this graph is x equal to A. Okay, so from the graph is obvious. Now you will ask, how do we do it mathematically, right? So the jump, the way we defined, that means the one side limits exist, but are different numbers. Okay, so like in here, this one's here at the A here, take a look here. If you are approaching from the negative, like left-hand side here, that means what is the limit here? This is L1. And the same way, if you approach from the right-hand side here, so what is the limit here? This is the limit is L2. So that's why they say the one-side limit exists here. Okay, but they are different here, right? So one side the limits they exist, but they are different numbers. So like this one's here at the A, so here is what is the L1 when you approach from left-hand side. The left-hand side limit is, you know, when you approach from left-hand side, when you approach from the right-hand side, both limits exist, but they are different. So that's why we mean a jump. Okay, so now the next ones here we talk about is removable discontinuity. Okay, so what is the removable discontinuity? So let's take a look from this graph here. So I know that we have two removable discontinuities. So this is x equal to b and x equal to c here. Okay. And so what is the we call this removables here? So we said here, right? So we say both the limit exists here, right? So for the f of the limit x approach to b, f of x, what is here? This exists. But we know the f of b is not exist. Right, so that's why I got an empty spot here. Then also the limit x approach to a, f of x exists. And then the f of a exists. They're just not equal to here. Okay, so the reason why we call it is removable. So here we say the discontinuity so both of these discontinuities are removable. Why? It's because redefining FB and FC and would make f of x continuous. Okay, so from these functions here, we said f of b not even exist. But here they said, hey, what you can do, see here, you can redefine. So I can say, hey, I can redefine the f of b to this value, to the f of the, to the L1, I can redefine it, so can fill this hole. And the f of the A, f of C is here, I can redefine in this value, so I can fill this hole here. Then let's will be make the f of x continuous. That's what we said, redefining here. So this is type of the, the discontinuity we call this removable discontinuity. That means if you redefine the values, then it will make the function continuous. That's why you can remove the discontinuities here. Okay, that's it. So that's for this videos here. So we talk about the very important, right? The definitions of what? The definition of the what? The continuous, right? So the continuous is one level higher than the limits. The limit not only have to exist, also has to equal to the function value. So it's very important. Then the other things we talk about is how do we define a function if you have a close parenthesis intervals here, right? So you need to consider right limit or left limits. Then also we talk about two kinds of discontinuities, jump discontinuity and removable discontinuity. Okay, that's it. And guess our next video will finish this section. We're going to talk about the intermediate value series here. Okay, nice to talk to you. Have a good day, and looking forward to talk to you in our next videos here. Okay, bye.